Today we're going to be doing some scatter plot graphs and then creating lines to fit. There are some key elements to this that you need to understand. First off, the points you pick don't actually have to be data points. That's very important. So even though there's a whole bunch of dots and data points on the graph, you don't have to pick one of those as your starting points to create the line to fit. That's one key thing. The second key aspect is try to have as many points above or close to as many points above the graph as you have below the graph. That creates the best line to fit. If all the points are below the graph and you create a line above it, that doesn't represent the data well. To represent the data well, you want about the same number of points above the graph as there are below the graph. And lastly, just pick some points that are easy to see on the graph. That will make making your line to fit a little easier, okay? Because you're going to pick the points yourself. The last thing I might add is that your answer may not match your neighbor's answer or the person that's doing the assignment with you. So you can have a different answer. It'll be close, but the slope may be a little bit different and the y-intercept may be off, depending upon what point you picked. So I'm going to give you an example of how we do these scatter plot graphs. So a person went out and they measured the height. They determined the height of trees based upon the diameter of the tree trunk. So this is something that a botanist might do. So here they have the height of the tree in meters. And you can see that they're measuring by 2.4 meters of the height, 3.2 meters of the height, 4 meters of the height. And that's compared to the trunk of the tree's diameter. That's how far across it would be if you cut it through the middle. So it gives us all this data, and all these little blue dots represent that data. So for example, up in here, that dot right there, if you look over on this side, if I go straight across from 3.2 and I go down here to 4, that's right in that area. Now you may say, well, why didn't you pick that point? Well, look out here as we go further. What's happening to the tree trunk stuff? It's starting to fall below this line out here. I might have been able to pick one a little higher, and that still would have been fine. That's what I mean by you might not match exactly. But I picked this one because it was a really nice point, meaning that the x-axis value was 6 and the y-axis value was 4. So this is saying if we have a 6 diameter tree on the trunk, it should be about the same as, it should be about the height of 4 meters. So if the diameter is 6 meters, the height will be 4 meters. We see that changes over time, and I tried to make, as I go out further, I'm going to see that these are falling below the line. So I try to make it about, it doesn't necessarily mean half and half, but if you can see what it's going to do, pick a point that would work and then also will give you some good data. So the other point I picked was down here. Notice we're counting by 4s or by 2s along this graph. So that's 2, 4, so this is 6, 4. So here we have 2. Okay, this is where the 2 would lie. So we're picking 2 and 2.4. So if the diameter is 2, we expect it to be 2.4 for the height. So these are the 2 points I picked on my line. It's key that you mark these points. Now there may have not even been one tree that was exactly 6 in diameter with a height of 4 meters, and there may not have even been one tree that was 2 in diameter with a height of 2.4 meters. But those are the 2 I picked, and that's what I'm going to use to answer some of these questions. So let's look at the questions now. Okay, so over here we have the questions. And this says, find the slope. Oh, sorry. I got it a little bit crazy here. So we're going to say, here's the questions. What is the slope of the line of best fit? What is the equation of the line of best fit? What is the approximate height of the tree when the diameter is 10 meters to the nearest tenth? And if the tree is only 2 meters tall, what is the expected diameter of the tree? So we're going to answer all those questions. So starting back at the first, we first need to find the slope of the line of best fit. Now we've already been doing slope, so this shouldn't be too hard for you to do. Remember, the slope is the subtracted y's over the subtracted x's. So the points I picked, remember, were 6, 4, and 6, 4, and I picked 2, 2.4. Those are the points I picked. Notice that the highest of those 2 points is 6.4. The lowest was the 2.24. 2 and 2.24. So it's always smarter to pick the highest point to start with, but you don't have to. Now remember, you have to start with the y's on top. Usually when people make a mistake, they put the x's on top, and that's where they mess up. So I have to use the y values, the 4 and the 2.4, on top to create my slope. So I did 4 minus 2.4 over, and then my x values, 6 minus 2. I added that together. 4 minus 2.4 gave me 1.6, and 6 minus 2 gave me 4. That equals 0.4. Now I could really use 0.4 as a slope, but I like to use always the slope as a fraction. So on your calculator, after you do 1.6 divided by 4, it'll give you 0.4. Use your F to D key, which is your second ABC key, and that will change it to 2 over 5. Make it a fraction. So 2/5 is the equivalent fraction to 0.4. So this is the slope we're using. Now what does that slope mean really? It means that for every 5 meters in diameter, the tree should go up, or the tree height should go up by 2 meters in height. So the height should increase by 2 for every time the diameter increases by 5. So that's the slope of the line. Now we're going to say, all right, we're going to write an equation for this. So I'm going to use the slope and substitute it into the equation y equals mx plus b. So I'm going to plug in the m value as 2/5. That's the slope I found. And y equals mx plus b, I'm going to use the y value from one of my points. And I'm going to use the 6, 4. So the y value is 4. The x value is 6. And the slope is this. Remember, I'm using the equation y equals, let me show you this out to the side, mx plus b. And my y value is 4 equals the slope is 2/5 and the x value is 6. I'm then going to solve for my y-intercept. So all I need to do is multiply this out. Well, the 5 and the 6 don't divide each other down. So I multiply the 2 and the 6. 2 times 6 is the 12 over 5. I subtract 12/5 to both sides. Hey, I got 4 over 1, but I can't add negative 12 over 5 to 4 over 1. So I need a common denominator. So I times the top and bottom of this one of 4 over 1 by 5. That gives me negative 12/5 plus 20/5, which is going to equal 8/5. That's the b value. That's where it will cross the y-intercept. So the height of the tree, usually a planter tree then, with not much of a diameter at all, is going to be a little over a foot, 1.4 feet actually to start with. So that's what we're using for planter trees, is basically what that's telling us. And then it's going to grow, again, for every 5 in diameter, it's going to grow 2 meters high. Now we're going to answer the third question. The third question says, what is the height of the tree when the diameter is 10 meters to the nearest tenth? Okay, we're going to do that. So we're going to say, we need to find the height, which is the y value, that's the key, that's what was being measured on the y-axis of the tree when the diameter was on the x-axis, is 10 meters to the nearest tenth. We're going to go back and use the same equation that I just found right here in question 2 to answer question 3. So I'm using y equals 2/5 x plus 8/5. Only this time I'm going to substitute in for x, the diameter of the tree, 10 to find the height of the tree. So if the diameter is 10, what will the height of the tree be? All right, well, I can do that. 5 divides the 10 twice, so 2 times 2 is 4, plus 8/5. Now this wants it in decimals anyway, so if I do 8/5, I'm actually going to get 1.6, and then I'm going to take 4 plus 1.6 is 5.6 meters in height. That's how high I expect the tree to be, is 5.6 meters when the diameter is 10. Now question 4 says, a little differently, if the tree is only 2 meters tall, so this means it's just after it got planted, what would we expect the diameter of the tree to be when the height is 2 meters? So this 2, because we're talking about how tall it is, the height, this is going to equal a y value, and we're going to solve for x. So still using the same equation I just had, I'm going to substitute in 5 for y. Or sorry, 2 for y. I'm going to substitute in 2 for y because I want to know when the height is 2, what is the diameter? So I'm going to substitute in 2 for y. Now I'm going to times the whole thing by 5 to get rid of those fractions. So I think that's what makes this problem hard, would be those fractions. But I don't want those fractions anymore, so I'm just going to multiply everything by 5. So I'm going to distribute a 5 all the way across. Don't forget to times the 2 by 5. So 2 times 5 gives me 10. The 5s will divide out here as I distribute it to this x value. So the 5s divide out, and I'm left with 2x. The 5s divide out on the y-intercept, and I'm left with 8. So now I have 10 equals 2x plus 8. Next step, obviously, is just to subtract the 8 from both sides, because I'm going to try and get this x by itself, so I'm subtracting 8. That gives me 2. And then I have a 2 in front of the x, so I'm going to divide both sides by 2. So x is 1 meter. So if the diameter is 1 meter, which isn't very big, if I have a 1 meter diameter, the tree will actually be, I expect the tree to be 2 meters high. All right, that's how you do those. I'm going to give you some examples from the assignment you're going to be doing, which is 4.4. And here is what you're going to do on a few of these. So number 1, you're just going to answer it the way it's given. It's pretty easy to do. And then 2 through 5, I want you to do this. I want you to tell 1A, or 2, on every one of these, I want you to answer 4 questions. A is just what it says. Tell whether x and y show a positive, negative, or no correlation. And then I want you to do, on B, if it's positive or negative, draw a line to fit. You can pick your own points, but again, try and make 2 points that show some up and some are below, and then make sure that they're points that you can use that are on the graph. They don't have to be actual points of the data. Then C, find the slope of the line you drew, and D, find the equation of the line you drew. Okay? And then number 6, you're going to do the following. You're going to graph the points on the graph and let the scale on the x-axis be by 2s and on the y-axis be by 4s. So do this one with me. So turn to your book, turn to your green book, and we're going to do number 6. So notice number 6 gives you a table of values. So I'm going to plot those values on here. So it gives me one at 0, 6. So again, I'm letting my x-axis be by 2s, 2, 4, 6, 8, 10. Remember, these are the x values, and the y values are on this y-axis. But I'm going to let them go by 4. So 4, 8, 12, 16, 20, 24, 28, so forth. All right, so I marked my point here. That's 0, 6. That was halfway between. And then I marked this point. This one was 2, 8. And then there's several other points up along here. Some of them a little below, maybe some above, but they kind of generally follow this. The 2 points I'm going to use happen to be points that were given. I'm going to use the 10, 20. So when x is 10, y is 20. and I'm going to use the 2/8. That seems to give me a good line to fit. I connect those points using a straight edge, either your calculator or a ruler or something like that, piece of paper, and I connect those. So now I'm going to do all of these things that I just mentioned up here. Now that I've drew those, I'm going to tell whether it's positive or negative. So if it's going up to the right, it's got to be what? Positive, just like the slope of the line. If it goes down to the right, it's got to be what? Negative, just like the slope of the line. If there is no correlation, meaning you just have dots everywhere and there's no linear correlation, then you just write no correlation. You'll see that fairly easy as you look at numbers 2 through 5. You'll see which one has no correlation. But this one definitely has a positive, and we're going to draw a line, which we did on number 6, and then we're going to find the slope of the line that we drew, and we're going to find the equation of the line we drew. So first we're going to find the slope using those 2 points, 10, 20, and 2/8. So using that, we're going to go 20. Remember, I always take the highest point first. It'll make your not have as many negatives if it's a positive slope. So here I have 20 minus 8, which gives me 12. That's the y's go on top. Don't forget to put the y's on top. Then we have the x values of 10 minus the lower one, which was 2. And those are the points. So remember, the points we had were 10, 20, and 2/8. So when I subtract the y's, 20 minus 8. When I subtract the x's, 10 minus 2. That gave me 12/8. I reduce that. 4 goes into both. 4 goes into 12 3 times. 4 goes into 8 twice. This becomes my slope that I'm going to use. So now I'm going to write the equation. Y equals 3/2 x plus b, with that slope being substituted in. Now I need to substitute in one of the points I chose. I could either use 2/8 or 10/20. Either one would work. I'm going to use the 10/20 because I'm pretty good at multiplying by tens. So I'm going to put in the 20 for y and the 10 for x. So I put those in. 20 equals 3/2 times 10 plus b. Well, the 2 and the 5 divide down, or 2 and 10 divide down to a 5. 3 times 5 is 15. I subtract 15 from both sides, and the y-intercept is b. Now, even though a point was given that told me the y-intercept was 6, don't let that throw you off. Remember, your line to fit is going to have a few points above it, and it may be the point that crosses the y-intercept. And it'll have some points below it, which may be where it crosses the y-intercept. In this case, the actual y-intercept is a little above our line to fit. Remember, the line to fit doesn't include every data point. It's kind of an average of the data points. So that's why don't worry about if your y-intercept of your actual data doesn't match your y-intercept of your line to fit. This line to fit is a good line to fit, even though it doesn't match the data of the y-intercept. It matches the overall data much better than the data, or much better than the y-intercept. Okay, so this is the equation we're going to use. The next thing we're going to do, according to number 6, because we've really done everything now that we are going to do on 1 through 5. We found the slope and we found the equation. But on 6, it asks us to describe what's happening with this stuff. So realize that what we're talking about when we're talking about the slope being 3/2 is that the y values are increasing 3 units for every 2 units the x values are increasing. So what does that mean with the stuff that we actually got and what it was measuring? Remember, it was measuring depth. Let me move this over a little bit. It was measuring depth for every centimeters that by centimeters. So it was measuring the depth of the bathtub by increasing by how many minutes you had the water on. So therefore, we have the depth is increasing by 3 centimeters because it was being measured in centimeters. So the depth of the water is being increased by 3 centimeters for every 2 minutes that I leave the water on. Okay, the water is running in the bathtub. Okay, now what does the y-intercept represent? Well, that's kind of interesting. It means the tub already had 5 centimeters of water in it before I turned the faucet on. Why somebody didn't drain the tub is beyond me. Maybe you ought to quit cutting your hair in the bathtub and clogging up the drain so that there's 5 centimeters of water in the drain before anybody takes a bath. I don't know why you're taking a haircut in the bathtub. Not a smart move. All right. So that's the majority of what we're going to be doing today. Let me show you a couple other questions I want you to add to what you're doing for class. So you're going to do set 4.4, 1 through 6. That's not a lot of problems. But I want you to do these two problems that I made up with some actual data. So I actually did this on the computer. I've always kind of wondered about energy usage. You hear a lot about the Green New Deal and how we're using too much energy and, you know, all that crap that they try to feed us. So this is what I said, is I said, well, let's think about this. What has been going on in the U.S. With respect to energy usage? Are we using a lot? Are we using not very much? What are we doing in the United States? So let me lift this up a little bit so you can see what we measured here. So I actually took the data that we had and I decided to measure it based upon what was going on in the United States over the last 17, 20 years, okay, close to 20 years. So the years are represented down here on this y-axis. That was the year 2000, all the way through the year 2017. So those are the years we have. So it looked like back in the year 2000, and this is when a lot of this, worry about green energy and we're going to run out of oil and holy cow, we're going to run out of everything. We need to conserve and we're using too much energy. And the amount of energy used in the United States is used by it's called tones, or TOE, which is tons of energy used, energy usage. You can look that up. That's actually a word, and it's how they measure energy usage. So they're measuring it in tones, which we had, for example, in the year 2000, we used, according to this, 2270 tones of energy in the U.S. in the year 2000. In the year 2001, just to show you what the data points mean, in the year 2001, we used 2225 tones of energy in the United States. Anyways, I plotted out all of those points exactly off the data. And it looked like up until about 2008, we were going way up. And then the recession hit. Now, some of you don't remember that, but the recession hit in 2008. And all of a sudden, our energy usage started going down. At the same time, we started having more and more solar, wind. We also started using more hybrid cars because people didn't want to pay the high gas costs. And all those things combined made a different line of energy usage. If you notice, here's the data points. All of a sudden, we have a trend downward with our data points since the year 2009 or 10. Okay, so I started really about 2010. And that's what those lines look like. So I decided, well, let's see what we would have done compared to what we have done. So this first line, I picked 2 points. Now again, those points probably weren't exact points of data. You can see, for example, in the year 2006, it says 2310 is the point I marked for my line of best fit. Well, in reality, we used a little under 2,300 tones of energy that year. But that doesn't matter. I'm trying to do the best line to fit as we go. And that's the line I use. So the points I'm going to use for this line from the year 2000 to the year 2008 is 22270, this point right here, and the point 62310. And then for my other line, which is after the recession of 2008, I'm going to use the year 2011, so that's the 11, and the number of tones we were using at that point was 2210. That's the point of best fit. Now really in that year we only used 2190, but the best fit line will be that one with 11 and 2210. Now the other point we're going to use on this graph is 16 and 2180. 16 and 2180. So I want you to rewind this if you need to. Mark this out on a piece of graph paper the way I have it marked out. And then I want you to answer these questions as part of the assignment. From 2000 to 2007, write an equation that shows the data line of energy usage in the US. So I want you to find an equation using those 2 points, 222.70 and 623.10. After you find that line, I want you to estimate what would have been the energy usage if things hadn't changed in 2008. What would have been the tones used in the United States if we had stayed on that line of trajectory in 2012? You're going to be surprised how much energy we would have been using had we stayed on that trajectory. But because of advancements in technology and different things that we started doing, plus the recession where we started just consuming less in general, we changed our habits and we have a new line of fit from 2010 to 2017. This line to fit will match this data, 1122.10 to 1621.80. And that's the points I want you to use to write an equation that shows the line of best fit for the data from 2010 to 2017. And then what would you expect energy usage to be in 2025 if we continue on this line of trajectory? You're going to be surprised at how far down our energy usage may be by that time. And if our energy usage of, and this is for fossil fuels. So really we're using a lot less fossil fuels now, and we're on a trajectory to keep and continue to use less fossil fuels than we were back before 2008. I think that's a pretty interesting and useful type of graph, and I want you to show that answer those questions based upon the data that we have.